Hey everyone, meet Gabrielle. Gabrielle is a farmer, and like many other farmers across the world, he falls victim to the idea that a lot of antibiotics is good at preventing bacteria from spreading, but this is not true. Think of it like a classroom full of students with a teacher who teaches the same lecture over and over again. Eventually, one student will have an aha moment and they can help the other students understand until everyone in the class understands what the teacher wants them to know. Similarly, for a single bacteria, if it is overexposed to the antibiotic, it can develop a mutation that makes it resistant to the antibiotic. And due to Charles Darwin's theory of evolution, this trait will be passed down from generation to generation until eventually the entire bacteria population is resistant to the antibiotic. But the solution to this is nanomaterials, and specifically silver nanoparticles. A nanomaterial is any material that has a dimension of 100 nanometers or less, and nanoparticles are a subset of that, where all the dimensions have to be 100 nanometers or less, where 1 nanometer equals 1 billionth of a meter. The most important thing to know about nanomaterials is that at the nanoscale, things don't behave the way that we're used to them behaving. And this is all down to an extremely high surface area to volume ratio. Thus, physical properties such as a substance's density and solubility will be dominated by its chemical properties such as its acidity and toxicity. So how do we obtain silver nanoparticles in the first place? So first, we have to start off with silver nitrate and then dissolve it in water. And then we have to add glucose and sodium hydroxide until eventually this chemical reaction yields metallic silver. However, one property of metallic silver at the nanoscale is that it is extremely reactive and it can agglomerate into bigger blobs of metallic silver. And we don't want this because if it is too big, it cannot bypass the bacteria's defense mechanisms and thus the entire process would be pointless. The solution to this is to add a capping agent, or PVP, which just prevents the metallic silver from agglomerating and forming an even bigger blob and keeping it nano-sized. Here in this graph, we can see that 0.75 grams is the optimal amount of PVP to prevent the spread of E. coli and other diseases. You might be wondering why specifically silver nanoparticles. Well, it's because silver at the nanoscale has a lot of interesting properties. For example, it's really efficient at absorbing light, and it's also a good conductor of electricity. These two are really important in other nanotech applications such as nanosensors, but in terms of biomedical application, the most important property is that it follows ion displacement, which just means that it releases silver ions that are detrimental to bacteria because of its high toxicity. So in this video, we're going to see an animation showing silver nanoparticles attacking a bacteria via ion displacement. So here we see the silver nanoparticles attaching themselves to the bacteria, and then it ejects the silver ions into the bacteria. These silver ions bind themselves to the DNA to prevent cell division, and they also bind themselves to the cell wall to prevent the bacteria from getting nutrients to go in and out of the bacteria. And finally, it blocks the bacteria's respiratory system, which essentially just stops the bacteria from gaining and using energy. These three things essentially force the bacteria to undergo apoptosis or programmed cell death because it has no other choice. So in conclusion, there are still a couple obstacles before we see silver nanoparticles into our daily lives. So firstly, the cost. Second, because of the extremely high toxicity levels, there needs to be more research conducted before we understand the effects of the nanomaterials have on our healthy body cells when they're actually inside our body and attacking bacteria. However, the potential of silver nanoparticles is so high, whether it is in agriculture, biomedical devices, clothing, shoes, gloves, whatever you can think of, you can bet in a couple years silver nanoparticles will play a huge role and change our lives.